This talk is going to be a little more nuts and bolts, basically a how-to of the Filecoin storage market system. My name's Hannah. I'm one of the primary authors of the market software that manages deals in Filecoin. You can find me. Oh, let me just make sure it's working first. Let's see that. Yes. Okay. Cool. You can find me on the internet at my handle is usually at Tech Girl Wonder. I use she/her pronouns. I work for Carbon 5. We're a product development agency that works with all kinds of clients from startups to enterprise. And we've been one of the sort of like long-term partners of Protocol Labs. Been involved in the development of Filecoin almost from the beginning. Yeah, we work on all kinds of software. So this talk is about diving into how storage works in Filecoin. And we're gonna talk about the process of putting data into the Filecoin network for storage. Here's what I'm hoping that you'll get out of this talk. By the end of the talk, you should be able to essentially understand the architectural goals of the Filecoin storage market. You should be able to recognize the transformations that your data goes through as it moves into Filecoin storage. And you're gonna learn some tips and tricks for making sure the deals you make in Filecoin are successful, and knowing what to do if they aren't. A lot of folks are just starting to make deals for the first time, and there's places you can get tripped up, and I wanna help you get through those. So let's talk briefly about the environment in which Filecoin deals are made. So like a traditional data storage environment is based almost entirely on reputation and trust. So for example, like if you're making a deal with Amazon, the only reason you have to believe that Amazon will actually store your data is because they're Amazon, right? And they're very well known. In the Filecoin environment, we don't rely on trust. We want to rely on each party demonstrating that they're behaving properly at each step in a way that's mathematically provable, ideally. So the analogy for storage on Filecoin is it's really like a market. You can think of it as almost being like an open bazaar for storage. To help us understand how this works, let's just think about real markets and how they work, right? So you show up at a giant market, and the first thing you need to do is you need to look at you have a discovery phase. You look at the different vendors, you see what's available, you find one you like, right? Next, you are probably going to talk to that vendor, and do a little bit of negotiation, a little bit of haggling over the price of the deal you want to make. Now in Filecoin, we're going to be storing data. So if you're going to pay someone to store your stuff, you got to move your stuff over to them. So we have a transfer phase. And now, once we've transferred the data and we've agreed, our negotiation is completed, we're essentially ready for everyone to commit to the deal. Usually you make it some kind of contract, it's in writing, and essentially through this exchange, everyone is now on board with what we're gonna do. Now, in the case, lastly, in Filecoin, what we're paying for is a service. We want someone to store our data over time, and we're gonna pay them at regular intervals. And it's really important that we can verify that we've got the right stuff. So just like if you were putting your own stuff into storage, you want to, and you're paying someone monthly to store it, you want to have a method of verifying that they're still storing it. So if we look at these steps in a deal, right, we have a discovery phase, a negotiation, a transfer, process of essentially sealing and committing to the deal, and we have a verifying stage. And essentially, these are the basic steps of a Filecoin deal. We use a couple of different pieces of terminology. When we seal our agreement, we refer to that as publishing because we are putting the deal that we're going to make on chain. And we refer to the final stage where storage is verified and funds are incrementally transferred as the proving. So let's talk a little bit about our goals at each step. These are the architectural goals of how we design the storage market. These are the things we hope to achieve. So in the discovery phase, as we discover providers and we ask them for the parameters that they're offering for deals, right? We want to make sure their offers are cryptographically signed so that we know a malicious party can't be falsely advertising on their behalf. When we get to the negotiation phase, we're mostly concerned about a provider here because a client's going to propose a deal, right? And we want to, and once the provider negotiates and agrees to the deal, they're going to then do a data transfer, which is a pretty big, expensive operation. So we want to make sure that our proposals contain everything that the provider needs to publish the deal, except the data itself, including a cryptographic signature from the client. Now we get to the transfer phase, and we don't want to do an expensive data transfer only to find out that we got the wrong data, right? So our transfer needs to be both verifiable, and ideally it should be verifiable incrementally. So all our transfer protocols for deals verify what is transferred. When we publish, this is the point where everyone is on board, and we need to make sure that we have various guarantees, right? A provider needs to know that the client has the money to pay for the deal, right? We want to make sure that later on, when they ask for, when they want their payment for storing the data, that is there. And the provider needs to know they have the exact data needed to that they need to store, because they're going to be asked to prove that they have it. A client needs to know that if something goes wrong down the line and the provider fails and loses their data or doesn't or fails to prove that they have it, then they need to be able to get refunded, right? They need to be able to get some amount of money back. And to sort of do the guarantees around money, we use an escrow system. Essentially, prior to publishing, each party puts funds in a form of escrow, and then when the deal is published, those funds become locked and they are released over time as the deal is proven. In the final stage, when the deal is published, we want to make sure that the client should only pay money for storing if the provider that can prove that they are still holding the data. This is an important guarantee that we want to offer. So those are basically the goals of each stage of the system of making deals on the Filecoin network. We've talked a lot about we've kind of covered the high level of the deal process, but we left something really important out, right? How do we actually get data into the Filecoin, right? So let's talk about that a little bit. Let's say we start with a file on our system. In the grand tradition of the internet, it is a cat picture, right? Now, a file on your system, a file that is on your regular computer system is identified by a file name. We'll say catpics.gif, and we want to put this in Filecoin. So the first thing we're going to do is we are going to take this system file and we are going to chunk it up using a data model called UnixFS. And we're going to use that to turn our system file into something called an IPLD DAG. DAG stands for Directed Acyclic Graph. It's essentially a graph where each root node contains verifiable cryptographic hashes for the child nodes. And this will become very important when we transfer the data and want to verify incrementally. You may have attended the talk earlier about IPLD, in which case you probably learned a little bit about more about what this data structure is. The IPLD DAG has an identifier, and we call it in Filecoin, we call it the payload CID. It represents the root of this DAG. And at this point, the format of the data is the same that it would be if it were in IPFS. And in fact, if we're going to put IPFS data into Filecoin, we'll start at this stage. And so this is going to be the format that we actually transfer data in because it is incrementally verifiable. Now, when we actually make a deal, what we make a deal for is something called a piece. And what a piece is the IPLD DAG serialized. We take this data structure and we write it to a flat file. And that file is called a car file. And then we have a little bit more, there's a few other things we need to do. This is called bin padding. We essentially end up with a piece of data and through a series of cryptographic transformations, that data has a unique identifier, and that is called the piece CID. We sometimes also call it COMP. The piece is what we are making the deal for. That is ultimately what the provider is going to prove that they have. And so the piece CID is what is going to go into our deal proposal, so that it is essentially what everyone is committing to. Okay, all right. So there are some other parts of transformation that happen on the provider side later on in the deal. I'm just going to briefly mention them, though we're not going to cover them in too much in depth. When the provider has published a deal, they're going to take that one deal, that one piece for the deal, and potentially multiple other pieces and pack them into a sector. So the sector is just a bunch of unsealed pieces, a bunch of pieces packed together, and it's identified by the value COMD. And finally, a miner is going to take that sector and it's going to apply a process called sealing, which is going to generate a unique copy of that sector, which will have its own identifier that is called COMR. Now, for the purposes of, this is mostly a overview and a how-to, so we don't really need to get too deep into what some of these things mean and some of the technical aspects of them. But I think it's really valuable because you're going to see these terms get thrown around, and particularly as you start to use Filecoin. And so it's useful to know what they are. You're going to hear a lot about, people will be like, am I supposed to use the PCID or the payload CID here? And it's good to know the difference, right? So along those lines, I've already started using a lot of terminology. And I want to just back up and just give you a couple quick definitions before we dive into like some real step-by-step of how all this works. So the first term is the storage client. We've already, used this a few times. The storage client is the party that's going to be storing data. And then the storage provider, which is usually a miner, is the party that is going to store the data in exchange for a payment. The storage market actor is another player in this. It is not, despite its name, a person. Rather, the storage market actor is software that is in the Filecoin system, and it's an on-chain piece of software. And because it's hard-coded, it's basically our trusted broker in all this. So you remember when I talked about we need an escrow system and we need to be able to track all the commitments for deals? That's essentially what the storage market actor does. And so when you publish a deal on-chain, you essentially submit it to the storage market actor and record our commitments on each side. We have a concept when we talk about figuring out what offers are, we refer to the current deal parameters that a miner is offering as a storage ask. You can think of it as somewhat analogous to an ask in a financial market. Then once you have essentially done all your transformations on your data and you are a client and you're ready to propose to a miner, you make a storage deal proposal. And the storage deal proposal is a proposal for the storage deal that is signed by the client. So if the provider has the data and they want to publish it, the client is essentially committed to it. And it contains the PCID, and that's really important because, again, that's what's going to go on chain and what the provider is going to prove it has. So that's the client side. Once the provider submits the signed proposal from the client with their own signature, it goes on chain, and then it becomes a storage deal. So that's once our deal is committed, we go on chain. Right. Awesome. So let's talk a little bit more in depth about how deals get made. So this is going to get a little technical, but I want to sort of walk through the entire process step by step, because I think it'll be really helpful for people who are trying to understand what's going on with their deal. Okay, so this is a flow chart of all the steps in a deal. You'll find this in the Filecoin specification. And I'm just going to walk through like what is actually involved in all these steps. I'm going to try to be as brief as possible, but hopefully this will be useful for some of you guys who are making deals. So the very first step is the discovery step. In the discovery step, the very first thing we can do is we can get a list of all the miners from the chain. That is something we can do. It may be something that the user of Filecoin who's making a deal does. Maybe they already know their miner. The next thing we do is we query for asks, so we can send a query to each storage provider we're interested in, and that'll respond with our current storage ask. Now we have decided on a provider, and we're going to go ahead and start the deal negotiation process. So before I even propose a deal, on the client side, I'm going to add funds into the escrow for the storage market actor. The provider is going to want to make sure, even before they do a data transfer, that I've put the necessary money in so that so that the deal can go forward. Then I'm actually going to run all the data transfers on my side to calculate the PCID or piece commitment. And then I'm going to propose the deal to the provider. The provider now goes into the process of verifying whether they want to accept this deal. They're going to probably run it against their existing ask parameters. They also can run custom deal decision filters and whatnot. They are going to make sure I put money into the storage market actor, and they're going to verify, and they're basically going to verify that the deal will go through if they accept it, right? So they are now going to send me back and say they intend to accept this deal once they have the data. Now we are going to transfer data, and there's a whole separate system for doing this. It's called the data transfer subsystem, and it has an underlying protocol called GraphSync. I did an earlier talk today about the engineering kind of fundamentals of this. I'm not going to do this go too in depth on this right now. Essentially, the client is going to open a separate request to the provider and say, I want to send you this data. The provider is going to verify that data against the deal, verify what they want to send against the deal proposal. And assuming that they verify it, they're going to accept the request to send data. Now data is going to go across. The provider is going to learn that the data is complete and that the transfer is complete. And the last thing they're going to do is they're going to take that payload and they're going to transform it again and verify that they have the exact data that will match the PCID in the deal they're about to publish. The provider is now going to put its own escrow money into escrow, and we are now ready to publish the deal. The provider is now going to essentially sign a chain message and submit the deal proposal to the chain with their signature. So now the deal is published on chain, and they're also going to let the client know that they've accepted the deal. The client will probably verify that the deal was in fact published. And at this point, we're going to hand it off to a system known as the storage mining system. And this is what's going to do those the sort of last phase of proving. What they're going to do, they will put the piece in a sector, they'll seal the sector, and then they will run these mathematical proofs over time to show that they have this data. And then the storage market actor will automatically transfer funds as the data is proven over time. And that's basically the process. Let's see if I have enough time to do a real quick live demo. Probably not too much time. I'm going to see if I can successfully run a deal with everyone watching from my own terminal. So let's see how this goes. All right, let me just see. I do not understand why. Sometimes I get this. All right, let's see. Are we on the terminal? Yes, we are. Okay. So on our left, we have a client. On our right, we have a miner. You can see that Lotus is running, right, on the client. First of all, I'm going to show you a couple commands that are really useful for me. I am going to start watching all my in-progress deals, and this is going to be done with Lotus client storage. Lotus client list deals. I am also going to run it with an option called watch, which people may not know about, and that will give me an ongoing output of my deals. Hopefully that will work. Now we're going to go over to another window, and I also am curious about what's going on with my transfers. So I'm going to run this other command called Lotus client list transfers dash watch. Okay, and that's going to give me my ongoing transfers. Lastly, now I've already imported some stuff into the Lotus data store, but you can see this by running Lotus client local. This will show you all the stuff you've already imported. I'm not going to import now because sometimes it takes a little bit. And you can see I've got about 4 files in there. They're not very interesting. I've got this, I have a little video that's about 200 megs large that I think we're going to try making a deal for, and we'll see how that goes. Over here on our other side, we've got our Lotus, our Lotus miner. It's running 2 different separate processes. One is Lotus, and the other is the storage miner. And I am going to start up the same commands over here. We're not going to actually run anything over here, so we're just going to use this this window to view our. Oh, you know what? Let me just close all of these guys. You do not need to know about my. weird notifications. And I'm just gonna go, so we're running the same analogous commands. Oh, goodness. Yeah, we are running the same analogous commands on the miner. So we're watching its data transfers, we're watching its storage proposals. Okay, now let's see if we can make a deal. Here goes nothing. All right, first of all, we're gonna wanna know if we have enough money. So I'm gonna just look at my wallet balance, which is gonna tell me, oh, oops, I gotta do it with the dot. Okay, yeah, I have some Filecoin. Now that doesn't mean it's in the storage market actor, but you can actually look at this. Some people have asked me about this, and let me just see if I can do this for you all. Some people have asked me, how do I know what I have in the storage market actor? And I'm going to do Lotus wallet. No, sorry, Lotus state market. Yes, state market balance, and I'm going to give the wallet, and it's going to tell me that I have this much in escrow and this much locked. Now, the reason I've got money in escrow already is because of some previous deals that I made mistakes on and that errored out, and so they're still in escrow. Pretty soon you will be able to get those back out with a command, which I actually think have in here, but is not available in Lotus, the last release, which is Lotus wallet withdraw funds, I think it is, and that'll move it out of the storage market actor. But I'm not going to do that right now. Let's just make a deal. Now, I find the easiest way to make a deal is with the interactive deal flow. If you're going to do it manually, probably because you're using the API, there's some concerns to know about, which talk to a few folks about. Okay, so let's put in a data CID. This is going to be, so data CID is the same as PCID. Sorry, rewind. Data CID is the same as payload CID. Sometimes those are used interchangeably, and that's a little bit unfortunate, but I'm going to use this one right up here for this video playback, and I'm going to go ahead and hit enter. Now it's going to do some calculations for me. I need to put in a deal duration. It has to be at least 180 days or more. So I'm going to put that in. Now I need to put in a miner address. And to do that, I am going to, actually, I can't remember what this miner's address is, so I'm going to run it over here. I'm going to do Lotus miner info. That'll give me, oh my goodness, this is not looking very good over the screen share, but let's hope that will. So, let's pull up our deals again. So I've got my miner info, and I'm going to paste it, right? You can see now it's making a query to the miner to get the ask. It's giving me a bunch of parameters, and I'm going to go ahead and accept it, which will start the deal. Now I'm going to attempt to pull up this window. Oh no, let's look at this window. No. How about this window? Here we go. You can see we've already got this deal, and it's already transferring, right? And we can actually look over here and see that the transfer is in progress. And we can look over here and we'll see that our deal, oh, there we are. Here we are. It's already going. Oh, now our data transfer is already done. This is all happening very quickly for me. So it's a little hard to track. Yes, and our data transfer is already done over here, so that's great. And you can see now over on this side, let's see, we are in this storage deal check for acceptance state, which basically means we're waiting for it to be published. And it's probably going to go through and finish those steps. Now, so a couple of things that you should know. One of the biggest hiccups. Oh, we're actually about out of time, but I'm actually gonna end that there. And if people have any other questions, in particular, there's tools for restarting data transfers I'm happy to cover. And I'm just gonna open it up to if there is any other quick Q&A, because it looks like we're about out of time, though I think we did start a minute or two late. So the first question I'm going to answer is, what do we do if do I have to run a full node to make a deal? At the moment, you do. At the moment, you need to run a full node to make a deal. However, we are building mechanisms by which someone can run a full node for you, and you can essentially have the node make a deal on your behalf using a remote signing architecture. What do we do if the provider goes bankrupt? Now, so there's some interesting challenges around this. This is kind of one of the important things that we do in Filecoin is we make sure that that the providers put up collateral so that we can verify that, you know, deals are going to work. One of the challenges is that providers could potentially commit to deals and then fail to prove a sector and lose some money. I believe at the point a deal is committed to, the funds are locked. So you're still going to get, so the client's going to be fine no matter what. And the providers, there's sort of some temporary issues at the beginning that are sort of coming up right now because providers haven't really gotten paid yet for some of their deal, for some of the sectors they're sealing, but that will probably go away over time. Where are we going to list a view of a Filecoin? Oh my God, I love this question. Where can we get a list of Filecoin commands? Okay, so from the command line, if you just type, hold on, I do not seem to have control of this. Let's see if we can do this. If you just type Lotus at the command line, you're going to actually get a list of the commands. And similarly, you can do the same thing on the other side with the provider. Now, this will give you the top level, and if we want to get into some more specifics, I can do Lotus client, and that'll give me all the client commands, and it just sort of keeps going down and is nested like that. Now, some of this is in the process of being documented, and I love your last question because I think we should totally build a GUI for this. There is a lovely HTTP API for all of these commands. They are all available from a programmatic API, and we could totally build a GUI on top of it. And I'm hoping that someone's going to build a really awesome GUI-based Filecoin client and maybe a GUI-based Filecoin miner manager at some point. Okay, I think I've kind of covered all of them, and yeah, that's it. Unless we have anything else.
Thank you so much for kind of walking through this with our audience here.
For sure. All right. Have a lovely rest of the Filecoin week, folks.